Well, hello there. In the 2.7a video, we talked about translations, which was shifting the function. Now we need to take it one step further, and in the 2.7b video, we're going to do stretches and reflections, two more types of transformations. So the essential question for today is, how do I stretch, shrink, and reflect general graphs? Since it's the same section, I'm going to attempt the same lame joke. Here are some things we're not doing today, and here's what we are doing today. How do all of these graphs, this one, and this one, how are they different than the parent function? How do they transform the parent function? So let's look at the parent function first. We're going to do our xy table, and this should be familiar. Instead of y, let's do absolute value of x. These should be familiar to you. When you plug in -2, the absolute value of -2 is 2. And with -1, it's 1, blah, 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 blah. We have some nice symmetry showing up. Your graph should look like this. And you're used to this parent function from before. It's the V-shaped thingy that we talked a bunch about and shifted all over the place. I need to talk about, though, this guy. So let me just switch ink color real quick. Pointer options. What color do we want? I'm feeling, ooh, purple sounds fun. Let's do purple. All right, so with y equals 2 times the absolute value of x, I'm gonna add room to my chart. Let's try plugging in some different values. So yeah, with -2, I have 2 times the absolute value of -2. We need to follow good order of operations here, so make sure to do the parentheses first. Absolute value of -2 is 2, times 2 is 4. Let's just plug in like one more example. 2 times the absolute value of -1. Again, good order of operations. Absolute value of -1 is 1, and then 1 times 2 is 2. And let's just fill in the rest because we know how it'll work. Let's graph this thing. Whoa, I gave the wrong y values there. This should be 2 and 4. Remember, it's symmetric. So over -2 up 4, over -1 up 2. My graph should look like this. And notice what's happening. This function kind of looks taller than the parent graph. And that is because, notice, every y value is exactly double the y value in the parent function. And that should make a lot of sense because we're multiplying by 2. So when we have a multiplier in front of the parent function, that counts as a vertical stretch. Let's see, though, what happens with this next one. And again, I'm going to switch colors. Let's see what I have at my disposal. Orange sounds wonderful. Orange is actually my favorite color. Maybe that'll be the bonus on the next test. Just kidding, it probably won't. All right, I have 1/2 times the absolute value of x. Now, just as with the last one, I'm plugging in the same x values. So 1/2 times the absolute value of -2. I'm going to follow good order of operations. Absolute value of -2 is 2, times 1/2 is 1. Same thing, 1/2 times the absolute value of -1. Okay, that's going to be positive 1/2. And then I have my symmetry. That can really help you. If you know it's symmetric, you can just fill in the rest of the values. Here's what this graph looks like. Over -2 up 1, over -1 up 1/2. And so on. Notice that these y values are exactly half of the parent function, and that should again make a lot of sense because I'm multiplying by 1/2. This counts as a shrink. So multiplying by 2 doubled it, multiplying by 1/2 halved it, it's a shrink. Let's see what multiplying by -2 does. And the last exciting color I can use, let's go back to classic light blue. So multiplying by -2 times the absolute value of x. Okay, -2 times the absolute value of -2. Let's see. Absolute value of -2 is 2, and then 2 times -2 is -4. -2 times the absolute value of -1. This absolute value would be 1, and then times -2 would be -2. And I am going to plug in some more values here just so that you can see what happens. Absolute value of 2 times 1, again, good order of operations. Absolute value of 1 is 1, times -2 is -2. So again, we're seeing the symmetry. The first half is the same as the second half. Here, notice what's happening. My y values, I'm actually going down this time. So when you plot those points, and I know I did it very quickly, but when you plot the xy points here, we notice that the graph is going down. So yes, this is a vertical stretch because I multiplied by 2, but also when I'm multiplying by a negative, that means I have a reflection because this graph is exactly the kind of downward reflection of the parent function, except I also stretched it by 2. So it's actually the exact reflection of this graph. All right? So let's review what happened here. When I multiplied by 2, it stretched it. When I multiplied by 1/2, in other words, a fraction smaller than 1, it shrunk it. And when I took a negative, when I multiplied by a negative, that reflected it. So let's talk about the general form. For every transformation, they are going to be the same for the rest of this year. So in this section, I was dealing with absolute values. But by saying f of, so like what does this f refer to? It's just kind of like the specific parent function we're talking about. So like later on, we'll talk about squares. In this function, we talked about absolute values. And we'll talk more about what that f means in class. Basically, it just means replace the f with whatever parent function you have. And then here's what happens with the letters. We just talked about the a, the thing that's multiplying the function. So on this slide, I have something multiplying the function in each case, multiplying that absolute value. The a, what we just talked about is, if I'm multiplying by something bigger than 1, it's a stretch. If I'm multiplying by a fraction in between 0, so bigger than 0 but less than 1, like a fraction, like in the last example it was 1/2, that's a shrink. And it will be a vertical reflection if the a is negative. So that's all what we talked about today. A review from yesterday is the h was the horizontal translation, and remember it's kind of backwards because of the minus sign. And then the k was the vertical translation. All right, so let's apply all of this general form to this next problem. I want to graph y equals -1/3 times the absolute value of x plus 1 plus 2. So here's the deal. Matching this up with the general form. Let me write the general form up here just so we can see what's going on. X minus h plus k. So this is the thing that I was talking about on the last slide. Notice instead of the f of, this particular parent function I'm doing is absolute values. So the f in this case is like, hey, I'm dealing with the absolute value function. The a is -1/3. The h is, it's 1, but remember because of the minus, that means shift left. And then the k is plus 2. So let's talk about how we're going to deal with all of these things, and this is what I would suggest. Start out by graphing the parent function. I know that the parent function in this case is y equals absolute value of x, and I know what those points are. You should have them memorized. The next thing we're going to deal with, because we have to work in order of operations, I'm going to deal with the thing that's multiplying the absolute value before I deal with the things that are adding to it. And again, it's order of operations. So first, I'm going to deal with this -1/3 as I'm thinking about how I'm going to manipulate my parent function. -1/3, remember, means that I am shrinking by 1/3. It also means that I am reflecting. So here's what that looks like, and let me just change colors so that we can kind of see what we're working with. I'll do the multiplications in red. So I need to reflect these points. I also need to shrink them. Here's what I mean by that. 0, 0. Let's think about the y coordinate of 0. 0 times -1/3 is still 0. So this point is going to stay the same. but all of these other points are going to change. They're going to be multiplied by -1/3. The y is going to be multiplied by -1/3. So this point, it needs to be 1/3 as high, so like here, but then it's being reflected as well. So instead of 1/3 there, it'll be 1/3 below the axis. How about this guy? It's too high, but it needs to be 1/3 of that, so that'll be 2/3, which is here, but again, I need to reflect it. This guy has a y-coordinate of 3. I need to multiply that by 1/3, which puts it at 1, but then it's reflected, so it's going to be down here. And do you see how I have a pattern emerging? Let's just do one more. A y-coordinate of 6 times 1/3 is going to be 2, except it needs to be reflected. So I have the graph doing this. And let's plot those same points on the other side because of symmetry. So I have my graph doing this. And this is just taking into account the shrink and the reflection. So that's step number 1. I just took into account the shrink and the reflection. Awesome. Now that I've done that, now that I've done the multiplication step, order of operations says next, do the addition. So remember what the h and the k do. This +1 inside the absolute values means I need to translate left by 1. Translate left 1. This means I need to translate up 2. So I'm going to take this new function that I already shrunk and reflected, and I'm going to make these changes. And again, it means literally taking every point and moving it over 1, up 2. So let's look at this point. Over 1, up 2. That would give me a point right here. Let's take a look at this point. Over 1, up 2 would give me a point right here. And let's take a look at this point. Over 1, up 2 would give me a point right here. These are 3 points, so I can start to make my graph. Notice I chose 3 kind of critical points, the one right in the middle, and then the 2, the kind of like the easiest whole value answers. So this green problem is my final answer. I started by multiplying the parent function to get the reflection and the shrink. Then I translated that shrink over left 1 and then up 2 to get my final reflected function. It's hard. We're going to practice it a lot, all right? The summary. General form, it's very important to know the general form. Remember the A, and this is the one that you do first. It either shrinks or stretches it, depending on what number it is, and if it's negative, it reflects. The H and the K, those are my translations. They're going to shift my function left and right. I do those after I do the A. All right, we'll practice more in class. See you then.